So in this video, we're going to talk about Gay-Lussac's law. Basically describes the relationship between pressure and temperature. So this law basically states that the pressure of the gas is directly proportional to its Kelvin temperature at constant N, or the amount of substance you have, and the volume itself. All right, and so for example, if we have a container, right? Within this container, the volume is 1.0 liters. All right, then we have pressure. The pressure here is 1.0 atm, right? And the temperature is 200 Kelvin, right? And so if you were to increase the temperature, right? So we increase it, let's say we double it. We double it to 400 Kelvin, all right? And this is still, the volume here is still 1.0 liters. Then what we find that this pressure here now has doubled. Since you doubled the temperature, you also doubled the pressure. So now the pressure is 2.0 atm. Okay, so it's a direct relationship between the two. All right, when one goes up, the other one will go up as well. All right, and so mathematically speaking, then, if that's the case, then we could say that pressure 1 is equal to temperature 1 equals to P2 divided by T2. All right, and this right here kind of shows us the relationship that they have, that they're completely direct. When one goes up, the other one is going to go up as well. Okay, so let's do like kind of a practice problem with Gay-Lussac's equation here. So what does the inside pressure become if an aerosol can with an initial pressure, so it has an initial pressure P1 of 4.5 atm, all right, is heated. So it's being heated in a fire from room temperature. So the room temperature, the first temperature is about 20 degrees Celsius, to the final temperature, the second temperature is 600 degrees Celsius. So the question is what is the pressure? What is the final pressure when it is finally at 600 degrees Celsius? All right. And so we're going to use this equation here to help us out. Now, first thing first is that the temperature units are in Celsius and it needs to go to Kelvin. Now, hopefully you recall that temperature for Kelvin, at least, it is degrees Celsius plus 273, and that's how you get to degrees. That's how you get to Kelvin. All right, from degrees Celsius. And so for both of these, I'm gonna add 273, so that way I could get my Kelvin numbers. And when you do that, the temperature 1 is 293 Kelvin. Temperature 2 is 873 Kelvin. Okay. And so I'm going to use this equation here. I'm just going to rewrite it. And so that way, or rearrange it, so that way I could have P2 on its own side. All right. And so I'm going to have P1 times T2 divided by T1 equals P2. Okay. And so when we do that, all right, what we plug in, pressure 1 is 4.5 atm. All right. T2 is 873 Kelvin, and then T1 is 293 Kelvin. All right. And if you notice, the Kelvins will cross themselves out. They're no longer relevant in this problem when you have to cross them out. And so when you multiply and divide this accordingly, we get about 13 atm.